Okay, this is going to be a lesson on Unit 1, Topic 2, Student Learning Task 10, Understanding the Relationship Between Rational Exponents and Radicals. And I fixed it there, and it might be wrong on all the other slides, but we'll get over it. Homework tonight is going to be Making Practice Fun 39, the Rational Exponents worksheet. Please be aware that if you do not show all your work, I am not going to give you any credit. What I'd like you to do is to please turn to page 35 in your packet and complete as many of the laws of exponents that you can remember. You should pause the video while you work on this. Okay, so I'm assuming everyone's had time to work on this worksheet, so let's see if we can remember how the laws of exponents work. When we multiply two bases that are the same, what we're going to do is we're thinking as x squared times x to the fourth, and my handy assistant is here, and when she adds these two numbers, she gets
6.
And that gives us x to the sixth. So when we multiply like bases, we are going to add their exponents. Alright, so now for number 2, if we had, oh, that does not look like a y. If we had 7y's and we divided that by 3y's, we would cancel off 1, 2, 3, and that's the same. Handy assistant, are you helping or not? Handy assistant, what is 7 minus 3?
4.
That would be y to the fourth. And so our law is if the bases are the same, we are going to subtract the exponents. Alright, now number 3, I do not need handy assistant for. The negative exponent just means it's 1 over a to the fifth. And that comes up because I don't really have a direct example of that. So let's just imagine for a second if we had a squared divided by a to the seventh, and again I cannot use handy assistant for this because she has not learned about negative numbers yet. If we did 2 minus 7, we would have negative 5, and that's because when I cancel them out, if you think about it, I'd have a 1, 2, 3, 4, 5, 6, 7, boom, boom, and these 5 are left in the denominator, so that is why a to the negative 5 is a 1 over a to the fifth. So we've got b squared to the fifth power, so we're going to have b squared 5 times. 1, 2, 3, 4, 5. And if we counted up all the b's, it would be the same as 2 times 5, which is
10.
Good job, handy assistant. So our rule over here on the right is going to be x raised to the m times n power. If I raise a power to another power, I multiply the power. Oh, and there's the rule for number 3. X to the negative m is 1 over x to the m. So, let's see what we've got left. We've got x to the 0 power. So, number 5, if we work through that, if we add the exponents, 3 plus negative 7 plus 0 would be c to the negative fourth, which would be 1 over c to the fourth. Here, I would add these exponents. 5 plus 7 is... It's 12, handy assistant. Come on. Hey, handy assistant, what's 12 minus 9?
Oh, that's 1. No, 3.
Can't get good help these days. Alright, so now we've got some multiplication. Negative 3 times 2. Again, handy assistant can't help us with negative numbers. She needs to leave. I might have to kick her out of the studio. And she's gone. Negative 3 times 2 is negative 6 times negative 5 would give us positive 30. We can fill this in. Let's see if we have an example that goes with that. No. So let's talk about this x to the 0 right here. This is another division rule. If we've got x squared over x squared, what's 2 minus 2?
0.
Good job, handy assistant. So common sense also tells me that anything divided by itself is
1.
Is 1. So x to the 0 is 1 because that means I divided something by itself if I had an exponent of 0. All right, number 8, going back to the left. No, do not do anything. Postpone. Hold on, my computer wants to reset itself. Sorry about that. My computer thought it wanted to reset itself. I said no thank you. And that's going to be d to the 5th. And then we've got some more difficult examples, but let's address these rules right here. If we've got multiplication going and it's raised to a power, it's just going to be x to the m times y to the m. Same thing here, this is going to be x to the m over y to the m. Alright, now number 9 and number 10, first we're going to distribute the 2. So power to a power we multiply. 2 times 2 is
4.
4. You're right.
4.
1 times 2 is, because we think about this as a 1. 5 times 2 is
10.
And then I'm going to recopy this guy. Don't be fooled. A lot of people are going to get messed up on this negative exponent here. We got to think about it like 4 minus negative 6, which becomes 4 plus 6. What's 4 plus 6?
10.
10. Handy assistant can't do negative numbers. 2 minus 3 is negative 1. 10 minus 3 is
7.
Now, I don't want to leave my answer like this. This is a really bad format. We don't want to leave a negative exponent, so our final answer is going to be... And again, that's just b to the 1st. You don't need the 1. All right, now you have 2 choices for number 10. You can simplify what's in parentheses first, or you can apply the exponent first. Because this is all multiplication and division, you wouldn't get a wrong answer, but let's follow the order of operations and do what's in parentheses first. So, I'm on my own because Handy Assistant can't do negative numbers. 5 minus 8 would be negative 3. And then over, oops. Now when I subtract, I would get 3. Because remember, negative 3 minus negative 6. And 3 times 4 is
12.
There we go. Alrighty, so that is your review of Algebra 1 exponent laws. Again, you can always go back and watch this again. If I went too fast or you missed something, it is available for you. Uh-oh. Circle of... There it goes. So everyone go ahead and flip to page 36. We're going to talk about the laws of exponents and how they relate to inverses and also to radicals. So it says explain why the square root of x squared is equal to the square root of x all squared, and this is all equal to x. And the reason is just simply the square and square root are inverse functions. Therefore, they undo each other. Okay, so what I want you to do is read number 12. I want you to box what I boxed. It says complete the equations below to help you determine what rational exponent. Remember, a rational number is the integer of the fraction of 2 integers. Sorry. A rational number is the fraction of 2 integers, so a rational exponent is just a fractional exponent, and that fraction has to be made up of integers. So determine what exponent is needed so that is equivalent to a square root in radical form. So think about that for a couple seconds. I need to multiply 2 times something because power to a power we multiply. 2 times something is 1. So the answer is this needs to be a 1/2. Same thing here. Go ahead and complete number 13. If you put 1/3 in each box for number 13, you're correct. So number 14 says, how would you express an nth root? Well, let's make this a little clearer here. If I have the square root of x, that's the same thing. A square root is going to be to the 1/2 power. If I have the cube root of x, that's going to be x to the 1/3 third power. If I have the fourth root of x, like what number multiplied 4 times? Like for example, if I had the fourth root of 16, that would be 2 because it's 2 times 2 times 2 times 2 is 16. The fourth root of x we would write as x to the 1/4. So therefore, if I've got the nth root, what number multiplied n times gives me x, I could write that as x to the 1/n. Alright, now, it is my belief that this is not enough practice on rational exponents, so I have a couple little exercises we're going to go through together. Grab your notebook or find a blank page in your packet to write these down. Okay, so let's just practice doing some rewriting. Take about 10 seconds and see if you can quickly rewrite these two with a fractional exponent and these two with radicals. If you wrote this one down as 6 to the 1/5, you're correct. If you wrote this one down as 17 to the 1/3, you're correct. For letter B, if you wrote this as the 8th root of 7 and the square root of 102, you are correct. Or 103, you're correct. Remember, the square root does not need a number in its root because that's our default root, the square root. Okay, so go ahead, again, just real quick, write these 6 problems down using a rational exponent. So in other words, give it a fraction exponent. I'll give you a 10-second head start. Okay, so for number 1, hopefully you wrote that as 11 to the 1/3 power. Number 2, you wrote down as 5 to the 1/4 power. Number 3, you wrote as 23 to the 1/5 power. Number 4 is 7 to the 1/2. And again, if there's no number here, it's a square root. Number 5 is 17 to the 1/3. And number 6 is 2 to the 1/6. Hopefully now you're comfortable rewriting between a radical and a fractional exponent, a rational exponent. So now what I'd like you to do is turn to page... Oh, I guess we're going to answer these awesome questions first. First, we're going to answer... Why are you laughing at me, Handy Assistant? Why does the square root of a perfect square result in the original number? They are inverses. What is the degree of a number or expression that does not show an exponent? Like if you just have x, the degree is 1. Like x to the 1. How can we express the square root of a number in rational form? Raise it to the 1/2 power. That looks like a y. And number 4, how could we express a cube root, a 4th root, an nth root? Raise to the 1/3 power. Why do I write ones? It looks like a y. 1/4 power. 1/n power. That was summarizing. Alright, I have a couple of problems we're going to work through just to practice. So, on page 37, it says evaluate each expression. That is not correct terminology. To evaluate means to use PEMDAS and come up with a single number answer. We are just going to simplify these algebraic expressions, and we are going to make sure we are going to first have answers in rational form. Remember, that means exponents are fractions. Okay. Two questions. Want to keep open? Alright, so the first thing I'm going to do is I'm going to rewrite number 15. In general, you're going to find that working with all of these radicals is a little tricky, but working with the fractions is going to be much easier. So first we're going to rewrite the square root of x as x to the 1/2 power. Then we're going to rewrite the 4th root as a 1/4 power. And the laws of exponents tell me when I have a power raised to another power, we multiply. So remember, I'm just going to multiply across the numerators. So 1 times 1 is... Are you helping or no?
1.
Good job. Okay, turn the shredder off. 2 times 4 is...
8.
Okay, and that's it. We're done. Ta-da! Yay! Okay, we're going to rewrite number 16. The square root becomes x to the 1/2 power. And then we've got a 5 here. 1 times 5 is...
5.
Okay, now be careful. This is like 5 over 1, guys. 2 times 1 is...
2.
And I'm done. Hooray! Don't multiply everything by 5. Number 17, there's really not a whole lot to do here, other than write it as 1 over x to the 1/3, which officially makes it the dumbest problem on the page. What's dumb? I'm glad you find this amusing. Alright, so number 18, we're going to start the way we started all the others. We're going to take our x to the 5th root of x and make it x to the 1/5. And before we all panic, we have x to the first power up here. I'm immediately going to think of this x to the first power as x to the 5/5 power. Because it's very easy to subtract 5/5 minus 1/5.
4/5.
I didn't even ask her for that answer. So again, this is like 3, and we're dividing the coefficients. 3 divided by 1 is 3, and then x to the 4/5. Okay, the bottom half of the page is very, very similar. We are simplifying, but now we need to leave our answer in radical form. So let's think. Number 19 is already written with exponents, so that's a bonus. I'm going to multiply across, and I'm going to have y. 1 times 1 is...
1.
2 times 3 is...
6.
But this is not how I want to leave my answer, because I want to leave my answer in radical form. So I'm going to write it as the 6th root of y. There's really nothing to do in number 20 other than rewrite it. So we have to think about d to the 3/5 as d to the 1/5 to the 3rd. And that's going to give us the 5th root of d cubed. You also could write that, like you could also think of that, first think of it as d to the 3rd to the 1/5. So you also could write it as d to the 3rd and then the 5th root of that. Alright, this last one, we are going to need some common denominators. We all can do this. So the common denominator between 3 and 2... Handy assistant, do you know the common denominator between 3 and 2? I'm going to go with no.
2.5.
2.5, you're a pain. How about 6? So I'm going to multiply this fraction by 2 over 2, and this fraction by 3 over 3. And I'm going to have x to the 4/6 minus x to the 3/6. And then what's 4 minus 3?
1.
So I'm going to have x to the 1/6. Again, first I created common denominators, then I subtracted. Now I'm going to write this as the 6th root of x. Right, we've got one more, and it's a big one. The first thing I'm going to do is simplify everything inside. Because if I first multiply by 1/2, I'm just going to create a whole bunch of fractions for myself, and nobody wants that. -5 plus 8 is going to be 3. Congratulations, but you don't really hit negative numbers until I am, so I'm assuming you don't. Alright, so now 3 minus 6 is going to be -3. Alright, so now just be careful when you multiply. Alright, now we want to be really careful because we want to give our answer as a radical. So the first thing I'm going to do is get rid of the negative sign with 1 over x to the 3/2. And again, just like up with number 20, you can think about it as the cubed first or the 1/2 power first. It makes no difference. I'm going to think about it as x cubed to the 1/2 power. And that's going to make my final answer for number 22 1 over the square root of x cubed. And that's that. Your homework tonight is making practice fun 39. I'm definitely checking it tomorrow, and you definitely should show all your work on a separate sheet of paper, because there is work to be done on a separate sheet of paper for this awesomely wonderful worksheet. The answers are right here. You are free to take a picture of it, screenshot it, look at it on Drive, whatever, to make sure you are getting things correct. However, if all you have are my answers recopied, you will not get any credit for this homework. Why are you laughing? Handy Assistant finds this amusing. My suggestion is to really read the directions. Get out of here if you're going to giggle. Alright, I'm going to just show you what I mean with number 22 by, oh, that's going to match too much, by reading the directions. Number 22, the directions say simplify as much as possible by first converting to exponential form. Then write the answer using radical notation if appropriate. So if I've got the 8th root of a to the 6th to the 1/8 power, now I'm going to have a to the 6/8, and I can reduce that fraction by 2, because 6 divided by 2 is
3.
And 8 divided by 2 is
4.
Boom. And so now that's how I got to here.